Hello and welcome to this video on the Functional Skills Mathematics Practice Paper 5 at Level 2. This paper comes with a bit of a warning for you that some of the questions really aren't the same as you would get in a normal exam. The questions are slightly more difficult and have 2 or 3 elements to them that you wouldn't normally get in the exam, and I'll point them out as we get to those questions. So let's start with section A, where you have no calculators, so you've got to do this part of the paper without a calculator, and you have 25 minutes and there are 15 marks available. So let's start with question 1, and this is one of those questions that I gave you a warning about, in so much as there are 3 or 4 parts to this question, and the question is quite difficult for the first question in a non-calculator exam paper. However, there is value in us doing the question to see if this question came up in a different section of the paper where you could give it an attempt. So question 1 says, work out the value of y if x squared plus 4y equals 185 when x equals 13. So if you can remember back to the formulas part of the course, you remember that the first thing to do is swap the x for the 13 to try and simplify this quite complicated looking formula. So we know that x squared means x times x, and if we swap x for the number 13, we get 13 squared. If you can remember what that is off the top of your head at level 2, that's fantastic. If you can't, then you can use your multiplication method, whichever one you choose, to do this problem. So 13 squared is 169. If you can remember that off the top of your head, you can just write it down. You don't have to show the working out for that if you can remember it. Okay, so now let's have a look and see what our formula looks like when we swap the x squared for 169. Now again, thinking back to our formula lesson, in order to solve an equation like this, you need to tell the story of y and then go back the other way. So that's how we dealt with it in the classroom. So the story of y, so if we put y in at one end, what's the first thing we do to y? We multiply it by 4. Then we add 169 and it gave us 185. So to find out what y is, we need to come back the other way and reverse the functions that we carry out. So if we start off with 185 at this end and we take away 169, so we've got 185, take away 169, we end up with 16 coming into the next section. And instead of multiplying by 4, we divide by 4. 16 divided by 4 is part of my times tables. I get 4. So work out the value of y. Y is equal to 4. Now here it's given you 1 mark, and what I was saying at the start about the warning is it's required us to do 2, 3, maybe 4 things to get to the answer, and that's not normal in a non-calculator paper. However, it is a good question that should have 2 or 3 marks and may appear later on in section A of the paper. Now let's have a look at question 2. Again, this question is slightly more complicated than something you might get at the start of a non-calculator paper, but it may appear later on in the paper. This question is going to test us on our knowledge of BIDMAS, where we have to do what is in the brackets first. So if we do 2.4 and we take away 0.9, you end up with 1.5 squared over 3 minus 28. Now, we have to do 1.5 squared. It looks complicated, but it isn't. It's just 1.5 times 1.5. And you need to remember we don't multiply decimals. We move the decimal point and keep a count, and we do 15 times 15. If you can remember what that is off the top of your head, you can just write it down. Otherwise, you can just use whichever multiplication method you find easiest to do 15 times 15. Now, once you've done your 15 times 15, don't forget to move your decimal point back, so we now have 2.25 as our value for 1.5 squared. So now we have 2.25 over 3 minus 28. Okay, so the next thing we need to do is divide 2.25 by 3. So 2.25 goes in the bus stop, 3 goes on the outside. 3 doesn't divide into 2. Take the 2 across, not forgetting to put your decimal point on your answer line. 3 goes into 22 7 times, which is 21, remainder 1. And then 3 goes into 15 5 times. So the outcome of 2.25 divided by 3 is 0.75. So we're left with 0.75 subtract 28. If you think of your number line, we've got 0, and positive 0.75 isn't very far away from 0, and we've got to go 28 that way. So our answer is going to be negative, and to find it, we've got to take away 0.75 from 28. So if you can't remember how to do that or have a quick method of doing that, the best way to do this is just have 28 with 2 decimal points, put the 0.75 underneath, borrow 1 and put them across. So 5 from 10 is 5, 7 from 9 is 2, and then you've got 27 left. So our answer is negative because if you think of our number line, we've gone to the left of 0, so it's minus 27.25. And again, all of that work is for 1 mark. So really, the marks don't reflect the number of processes you needed to carry out to get that answer. So a question like this could appear later on in the non-calculator paper, but it would be worth 2 or 3 marks.
Question 3. The diameter of a sphere is 42 meters. What is the surface area of the sphere? They've given us a formula here where A equals 4 pi r squared, where A is the surface area in meters squared, r is the radius in meters, and pi is a fraction. It's 22 over 7. So we really need to keep the fraction as a fraction. So let's write out the formula substituting what we know. So A equals 4 times pi, which is 22 over 7, times the radius in meters. Now they've given us the diameter, so it's one of those trick questions where we have to divide the diameter by 2 to get the radius. So the radius is 21 meters, and we need to square it. Now in this situation where we use the fraction, we've said the squared number we need to write out as 21 times 21, rather than 21 squared. The reason we do that is for the next stage, where we're going to not do that, we're going to do that. So 21 divided by 7 is 3. So our problem becomes 4 times 22 times 3 times 21. We know 4 times 22 is 88, so that's the next stage, and then we need to do 88 times 3. So we've got 88, and we're going to multiply it by 3. So we end up with 264 times 21. So this is quite a large multiplication for us to do. So let's break it down and do this final calculation. So we end up with 5544 as the answer to our last calculation. So the surface area in meters squared of our sphere is 5544 meters squared, 5,544 meters squared, and all of that working out for just the 1 mark.
Question 4. Which one of the following lists is in decreasing order? So we've got a mixture of fractions, decimals and percentages, which takes us back to the loop of life. So all of them are the same fraction, decimal and percentage. We just need to find the right order. Now, I've always reminded you in the lessons that 1/5 as a decimal is 0.2. 5% means 5 divided by 100, so that's 0.05. That's our 5%. 17 over 50, if we turn it into a percentage, is 34%, and then if we turn that into a decimal, we have 0.34 for 17 over 50. So we used equivalence to turn it into a percentage because that was quick and easy, and then to turn 34% into a decimal, straightforward, just move the decimal point 2 places. And then our final number is our decimal. So we have to put them in decreasing order. So the largest number comes first. So our largest number is 0.34, which is our 17 over 50. So we're looking for a list that has 17 over 50 as the first number, and then we can tick the box that has that because no other list has 17 over 50 as the biggest number. And that was it. So question 4, 1 mark, you need to select D. Question 5. What is the perimeter of this triangle? Well, they've given you 2 angles and you know the angles to a triangle add up to 180. Or if you recognize it, if 2 of the angles are 60, then the last angle must be 60 degrees. And with all of the angles being the same, this is an equilateral triangle. Therefore, all of the sides are the same length. So we have 24 plus 24 plus 24. Or you can multiply 24 by 3, whichever's quickest for you. So it's 72, and they've already given you the units, which are millimeters. And this is a pretty standard 1 mark question for the non-calculator paper, and that's worth 1 mark. Question 6. What is 108 as a fraction of 648? Give your answer in its simplest form. So we create our fraction using the 2 numbers we've been given. And what we need to do is to simplify it, find a number that divides into both. And you can do this as simply as you like by saying both of them are even, so I can divide by 2. Or if you can see another number that goes into them, then you can use that number. So let's just use the simplified version and say they're both even, so we know they divide by 2. So 108 divided by 2, if you're not sure, just use your bus stop method. That's 54. And the same for 648. That's 324. Again, they're both even, so you can divide by 2. Don't be frightened of continually using your bus stop. So, by dividing by 2, we end up with 27 over 162. Now, We're looking at 27 and we're saying it's an odd number so it doesn't divide by 2, but I know it divides by 3. So let's just check if 162 divides by 3. Well, 3 goes into 16 5 times, remainder 1, and 3 goes into 12 4 times. So yes, it does. So if I divide by 3, my numerator, I get 9 over 54. Now at this stage, you're starting to recognize numbers from your times tables. So I know 9 goes into 9 once, and I know 9 goes into 54 6 times. So if I divide by 9 this time, I get 1 over 6. So that speeds our process up a bit because I've recognized 54 being divisible by 9. So our answer for 1 mark is 1/6. Question 7. A call center aims to deal with calls in less than 5 minutes, and calls come in randomly. The table below shows data for the calls made to the center. So the proportion of the calls is a fraction, and the completed in less than 5 minutes is a percentage. Work out the probability that the next call will be a customer complaint completed within under 5 minutes. Give your answer as a fraction in its simplest form. So the customer complaints is this row here, and the proportion of the calls is 1/4. Completed in less than 5 minutes is 60%, and we know 60% as a fraction is 60 over 100, which we can simplify to 6 over 10, which again simplifies to 3/5. So to work out a combination of probabilities, so something and something else, we said in our probability lesson, you need to multiply them. So we've got to multiply our quarter for the proportion of the calls by the completed calls in less than 5 minutes, which is 3/5. In the fractions lesson early on in the course, we teach you to multiply fractions, which is top by top, so 1 times 3 is 3, and bottom by bottom, which is 4 5s are 20. Now, you've got a fraction as your answer. Can you simplify it? Well, no, because we know 3 is a prime number, and 3 doesn't divide into 20. I don't have to try and simplify this anymore. So your answer for 1 mark is 3 over 20. Question 8. 43 over 8 minus 3 and 3/16. So we have an improper fraction and a mixed number, and we can do this by using either method that you've shown in the classroom. So let's turn them both into improper fractions. So the first way we do that is convert our 3 and 3/16 into an improper fraction. So 16 times 3 is 48. So we've multiplied the 16 by the 3 to get 48, plus the 3 is 51 over 16. So our problem now becomes 43 over 8, take away 51 over 16. We now need to use equivalence, so we can keep the 51 over 16 as it is, but we need the first fraction to be over 16 by multiplying by 2. So to get from the 8 to the 16, I multiply by 2. We need to multiply the 43 by 2, which gives us 86. So now we can do the maths. 86 subtract 51, let's not take any chances, is 35 over 16. So now we've got it as an improper fraction, we can turn it back to a mixed number. So 16 goes into 35. Well, 16, 32, it goes in 2 whole times, and that's 32. So take 32 away from 35, and that leaves 3 over 16. So our correct answer is C, 2 and 3/16. Question 9. 4.025 divided by 0.05. So we've always said when we did division of decimals that you can't divide by a decimal. So the number doing the dividing needs to be made into a whole number by moving the decimal point 2 places to the right. So our problem becomes divided by 5. Now remember what we said in the lesson. What you do to one side you do to the other to give us equivalence, so whatever the answer is, it doesn't need changing. So we move the decimal point for the other number 2 places to the right, and we end up with 402.5. Now when we do this division, whatever the answer is, that's the answer to our question. So 402.5 divided by 5. 5 doesn't go into 4, carry the 4. 5 goes into 40 8 times. Exactly. There's no remainder. 5 doesn't go into 2. Put in your decimal point and carry the 2. 5 goes into 25 5 times. So you have 80.5 as your answer. You do not have to do anything with the decimal point because we used equivalence when we were setting up our division. And that answer is worth 1 mark. Question 10 is your knowledge of shapes, and what they want to know is what is the angle at B. So the first thing to do is work out how many sides our shape has. So there's 1, 2, 3, 4, 5, 6, 7, 8 sides. Now remember what we said in class. A 3-sided shape had 180 degrees. We know the angles inside a triangle add up to 180 degrees. A 4-sided shape were 360, so every time we add a side, we add 180 degrees. So let's carry on doing this process. 5 sides gives us 540 degrees. 6 sides gives us 720. We're adding 180 every time. 7 sides gives us 900 degrees. Therefore, an 8-sided shape is 1080 degrees. We just kept adding 180 degrees every time we added a side. So we know that the sides inside an 8-sided shape add up to 1080. So to work out what one of the angles is, because they're all the same, this is a regular pentagon, so all of the angles are the same, we divide 1080 by 8. 8 doesn't go into 1, carry the 1. 8 goes into 10 once, carry 2. 8 goes into 28, 8, 16, 24, 3 times, remainder 4, and 8 goes into 40, 5 times. So the internal angle of our polygon, our octagon, is 135 degrees. Now if you notice, the angles are on a straight line. And we've just worked out that this angle is 135 degrees and B is here. So to find what B is, we subtract the 135 from 180. And we end up with 45 degrees as our angle for B. And that's worth 1 mark. Question 11. A woman brings a ring to a jeweler. She says it's a platinum ring. The jeweler knows that the density of platinum is 21.45 grams per centimeter cubed. The jeweler weighs the ring and finds its volume. Is the woman correct? Explain your answer showing your calculation. So there's a couple of ways of doing this. We've been given the density of platinum, so we know that there is a relationship between grams and the volume in centimeters cubed, and there's 21.45 of these to one of those. Now we've got two options here. We could either use the mass of the lady's ring or the volume, depending on what we want to do, and the easiest thing to multiply is the 1.5. So we're going to use this to check that the weight of the ring ties in with the density. So what we need to do is multiply. So this problem comes down to multiplying 21.45 by 1.5. Again, we don't multiply decimals, so we move the decimal points out, so that's 3 decimal places moved, and we now have to multiply 2145 by 50. So let's break that down into our box method. So we've got 2,145, and we're going to multiply it by 15. So we've got 32,175, not forgetting to move our decimal point back 3 places. So we end up with 32.175 as the weight of the ring if it was platinum. So by using the volume, we've worked out that her ring does not weigh enough to actually be a platinum ring. So answering the question, is the woman correct? Well, no, she's not correct, and say that the weight is almost half of what you would expect if it was platinum. And all of that work is worth 1 mark. Question 12. A driver sees this speed limit on a sign in France, and the speed limit is in kilometers an hour. We have a relationship given to us that 1 kilometer is 5/8 of a mile. So they are driving at 80 miles an hour. They think this is below the speed limit. Are they correct? And explain your answer showing your calculation. So using our strap line, we've got kilometers to miles, and we're being told that 1 mile is 5/8. We know the limit is 130 kilometers per hour, so we've multiplied this side by 30. So all we need to do is do 5/8 times 130. And so this becomes a fraction of an amount question. So our rule for doing this is don't do that, do this. So we divide 130 by 8. 8 doesn't go into 1, carry the 1. 8 goes into 30 once, remainder 5. 8 goes into 50 6 times. We've reached the end of the queue, so 6 8s are 48, we have a remainder of 2. 8 goes into 20 twice, which is 16, remainder 4, and then 8 goes into 45 times. So we know that 130 divided by 8 is 16.25. All we need to do now is multiply 5 by 16.25 to work out what 130 kilometers an hour is in miles an hour. So move the decimal point and multiply 5 by 1,625. So that's 5,000 there, 3,000 there, 100 there, and 25 there. Add them together. Don't forget to move the decimal point back the 2 places. 130 kilometers an hour is 81.25 miles per hour. So they're doing 80 miles an hour. So they think they're below the speed limit. Yes, they're correct, as the speed limit is 81.25 miles per hour. The last question then. A man has a fish tank with the following dimensions: 24 centimeters by 29 centimetres by 41 centimetres. And he needs to know the approximate volume. So we're going to do some rounding. We're going to have 20 times 30 times 40. So 2 3s are 6 with 2 zeros that we missed out. And then 6 4s are 24 with 1 2 3 zeros that we missed out. So the approximate volume in centimetres cubed is 24,000 centimetres cubed. And that is worth 2 marks. That's the end of section A for practice paper 5.
Now let's do section B, where we're allowed to use our calculators. We have 1 hour and 20 minutes and there are 45 marks available. The first question, question 1. I have 0.06 million and I need to divide it by 6.2 thousand. And we need to give our answer to 2 decimal places. So as we said in class, the way to do this is write your millions as 6 zeros. And we've got the decimal point there to say where the whole millions would have started. So if we had a million, it would go there. But we've got 0.06. So really, we're talking about 60,000. Can you see how we lined it up? So we've got 60,000 and we need to divide it by 6.2 thousand. So the same with the thousands. 1,000 is 3 zeros, so the 6.2 would go there, so it's 6,200 that's going into our division. So let's put that into our calculator and see what we get. If you get a fraction, don't forget to press SD. And the answer on the calculator and that's good enough because this allows us now to look at our decimal places. Now, when you looked at the answer, it was recurring between the 6 and another number further along that we can't see. That's why the little dot is over the 6. But we don't have to worry about that because we've got the 2 decimal places we need. So we need to round it to 2 decimal places. Look at the next number along, which is a 7. So the 7 that we're interested in needs to go up to an 8. So our answer to 2 decimal places is 9.68. Question 2. What is 3 over 87 as a decimal correct to 3 decimal places? So all we need to do here is use our calculator. Put the fraction in by pressing the fraction button, and it's 3 at the top. Use the rocker switch to go down and put in the 87. Press equals and then press the SD button to get it into a decimal. So the decimal, when we put it into our calculator, had a recurring over the 0, which doesn't really mean anything because we couldn't see the second recurring dot on our display, but we're only interested in 3 decimal places. So we're going to chop this number off here. Now, the next number along that we're interested in is a 4, so our 4 remains at 4. So our answer to 3 decimal places is 0.034. Question 3. The diagram shows the outline of a building, and the front of the building is labelled. Which of the above diagrams shows the elevation from the left side of the building? So the left side of the building is looking in that direction. So we would see the rectangle for this bit and then the side of the prism on the other bit, and it would be flat onto us. So we're looking for something with a rectangle and then something flat above it. This wouldn't be exactly side on, and neither would this. So the diagram for exactly side on should be C. So tick box C. Question 4. 1 metre cubed is the same as which of these options in centimetres cubed. So we know that 1 metre cubed means we have a cube with 1 metre by 1 metre by 1 metre. So all we need to do is convert each of those three dimensions into centimetres. So 1 metre is 100 centimetres. And what it's asking us to do is multiply 100 by 100 by 100. So we don't have to do this manually, we can do this on our calculators. And we get 1 million as our answer. So the option to tick is option D for 1 mark. 1 metre cubed is the same as 1 million centimetres cubed. Question 5. A social club sells 50 pink raffle tickets and 75 yellow raffle tickets. Tickets are drawn randomly. What is the probability that the first ticket drawn will be a pink ticket? Give your answer as a decimal. So, we've got a total of 50 plus 75 tickets. So put this in your calculator to get 125 tickets in total. We're looking for the probability of a pink ticket. So that is 50 over 125. So if we put this in our calculator, and we can actually put it in as a division or a fraction, it really doesn't matter. Now it wants the answer as a decimal, so press the SD button and we get 0.4. So 50 over 125 is 0.4. So the answer for 1 mark on the answer line is 0.4. Question 6. The chart shows the finishing times of marathon runners. A report states that most of the runners finish in under 4 hours. So our 4 hours is here, so they reckon there are more people finished in under 4 hours, i.e. to the left of our cutoff line. Is the report correct, and explain your decision? Well, you can see from the right that there's actually more data, there's actually more grey shaded area, and that will actually do as a reason. So because there's more grey shaded area, that means there are more people. So explain, is the report correct? No, it's not. And the explanation would be along the lines of there is more data stroke people to the right of 4 hours. And that should do as an explanation. Again, this is worth 1 mark. Question 7. A shop has a sale and there is 30% off all black tag items. One day, this notice appears in the shop and it says one day only, black tag an extra 25% off the marked price, saying that it's better than half price. A customer explains that the notice is misleading because it is incorrect. Is the customer correct? And explain your decision, including calculations to support your decisions. So, what we need to do first is work out the original price after the 30% drop. So we know the new price is 21 and it dropped by 30%. So we've multiplied by 0.7. So in order to find the original amount, we divide by 0.7. So 21 divided by 0.7 on our calculators gives us £30 as the original price. So the original price was £30. Now, one day only, the black tag takes an extra 25% off the £21. because that's the marked price that we have up here. So let's do 25% of our £21, which is our tag price. You can put this straight in the calculator as it looks, not forgetting where the percentage sign is on your calculator. So on this particular calculator, it's above the left-hand bracket. And then we're going to multiply that by the £21, press SD, and it's £4.41 is an extra amount we're going to take off. So we've got £21 and we take off £4.41. Again, no need to risk anything. Let's do this on our calculators. And that's £16.59. So £16.59. Now, is the customer correct? Yes, the customer is correct, because if it was less than half price, the item would be, now we've got £30, we divide it by 2, which gives us 15, so it would be less than £15, because £15 is the half price amount. And then it is above this with the extra 25% off. So anything along those lines. So you're working out, it's going to be a couple of marks and then 1 mark for your decision and explanation. So there are 3 marks for question 7. Question 8. A craftsman uses resin to make a paperweight. He makes the paperweight from 2 parts, a hemisphere and a cylinder, and he uses this plan. The plan also shows the dimensions for certain parts of the hemisphere and the cylinder. How much resin does he need? So the volume of a hemisphere in centimeters cubed is given to us, so the hemisphere is given to us as V equals 2/3 pi r cubed. So let's do the hemisphere first. So the volume of our hemisphere is 2/3 times pi, which we'll use 3.14, times the radius cubed. Now, since the hemisphere joins our cylinder, that's 7 centimeters as a diameter. So 7 divided by 2 gives us 3.5 centimeters as the radius for our hemisphere. So 3.5 cubed. So let's put that into our calculator. Now this time we need to use this button here to give us our indices, because normally we use the square button, but if we use this one here where it's got the little block on it, we can actually tell it what to put as our index. Now when we press equals and SD, we get 89.7516 recurring. Now all we need is the volume of our cylinder. So let's do that, and we need to remember this. This is one of those formulas we need to remember, that the volume of a cylinder is pi r squared times the height of the cylinder. So we know pi is 3.14, The radius we've already calculated for our cylinder from our diagram, which is 3.5 centimeters. So we need to square that times the height of our cylinder, which we're given here as 5 centimeters. Again, all we need to do is put this into our calculator and find our answer. So our answer is 192,325 centimeters cubed, as it's our volume, and centimeters cubed for our hemisphere as well. So to calculate the total volume of our paperweight, we need to add our two amounts. So we have 192.325, and we're going to add it to 89.7516 recurring. We're going to put this in our calculator and find out what our answer is. So our answer is 282.0766 centimeters cubed. So put our answer on the answer line. Now I would put the complete answer in because they haven't asked us to round. So I would put 282.0766 centimeters cubed because we've not been asked to round it. Question 9. A gardener wants to build this greenhouse in the top right-hand corner of their garden. This is a sketch plan of their garden, which is shown here with the dimensions. They will leave a 50 centimetre space between the greenhouse and the edge of the garden, and they want a scaled plan of the garden to show the position of the greenhouse. Draw a scale plan and put the scale you use on the plan. So the biggest dimensions we've got is 5.5 by 5.5 on here that we need to fit on our plan. So using the paper they've given us, we need to choose a sensible scale. So if we choose from there to there as 1 metre, can we get 5.5 or even 6 across and down? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, we can. So that's the scale we'll go for then. It makes the most of the paper and we know it fits the biggest dimensions onto. So let's put our scale somewhere in our drawing where it won't get in the way. So from here to here we've said is 1 metre. Now, this allows us to do the big drawing because it's nice chunks of ones and halves of meters. So let's just draw the garden on here first, starting in the top left and making the most of the paper. So across the top, we've got 1, 2, 3, 4, 5.5 meters. And down the side, we need the same. 1, 2, 3, 4, 5.5 meters. On the left-hand side, we've got 4 meters coming down from the top. So 1, 2, 3, 4 meters from the top. And then we've got 2.5 meters across the bottom. So 1, 2.5. And from the drawing, we can fit in the missing numbers. So if it's 2.5 from there to there, then it must be 3 from here to here. If it's 5.5 from top to bottom, and we've got 4 here, then this measure from here to here must be 5.5, take away the 4, which is 1.5. So we've got 1.5 meters in here. So back to our drawing, we need to draw 3 meters from this point here. So 1, 2, 3, and then it should be 1.5 to join up with the other bit, which it is. So we've drawn our garden, and as you can see from the graph paper, we've made the most of the paper to get the best scale. We've also kept the maths nice and easy for ourselves because we've just used chunks of 5 or 10 squares to represent half a metre or 1 metre. Let's do the shed then. So the shed needs to be 50 centimetres away from any particular wall. So 50 centimetres is a half of our scale. So our scale is 10 squares is 1 metre. And we've got half a metre or 50 centimetres. So we need 5 squares as a bit of a border to protect our shed from the edge of the garden as it requests here. Now we've calculated the gap we need between the garden wall and the greenhouse, let's have a look at where we need to place the greenhouse. And if we go back to the top of the question, you can see the gardener wants to build the greenhouse in the top right. So we need to be putting our shed in the top right-hand corner. So now if we go back to our diagram, and we put our gap of 5 squares from the top right, we count 5 down and 5 across. So that's our 50 centimetres. Then this is going to be the top corner of our shed. So now we can draw the dimensions of our shed, which is 2 metres. So that's 1, 2, 3, 4 squares, because 2 squares is a metre, remembering our scale. And then 1, 2, and then that's the half a metre. So we've got 2 metres wide and 2.5 metres deep. Now, once we've drawn our diagram, don't forget to label everything. So this is our greenhouse. And that's dimensions are 2.5 metres by 2 metres. The left-hand side, 4 metres, so just like our diagram, 2.5 metres on that side, 5.5 metres on this side, and across the top, 5.5 metres. So it looks just like the sketch, but on our graph paper. And all of that work is worth 4 marks. Question 10. A student wants to raise £100 for charity, and they will sell hot dogs at a disco. They will make 150 hot dogs, and they buy ingredients at the supermarket. The supermarket has hot dogs, a tin of 8 for 50 pence, and hot dog buns 6 for 90 pence. If they sell all the hot dogs, what is the minimum price they must charge? Okay, so the first thing we need to do is work out how many packs of hot dogs and hot dog buns that we need for our 150 hot dogs. So 150 divided by 8 will tell us the number of tins of hot dogs. So that's 18.75. So you can't buy 0.75 of a tin, so we need 19 tins of hot dogs. Let's do the same for the buns. So we want 150 hot dogs. There are 6 in a pack. And that's exactly 25 packs. So now all we need to do is work out the cost. So we've got 19 tins multiplied by 50 pence is £9.50. And 25 packs of the buns at 90 pence is £22.50. So let's add all that together. So £22.50 plus £9.50 is £32 on the hot dog makings. They want to raise £100 for charity, so we'll add the £100, and what we're looking for is £132. £132 is the minimum amount they need to make. So if we take our £132, divide it by our 150 hot dogs that we're going to sell, it's exactly 88 pence. So on the answer line, the minimum price per hot dog would be 88p. And that's worth 4 marks. Question 11. A supermarket buyer compares large eggs from 2 suppliers. The table shows the masses of a sample of large eggs from supplier A. A similar sample taken from supplier B gives you a mean value of 66.5. Which supplier should the buyer use, and explain your decision? So we've got a mean for supplier B. What we need to do is work out a mean for supplier A. So when you're given a range of numbers, what we need to do is take the midpoint between 63 and 65, in other words 64, and multiply it by the number of eggs. So we're going to do that for each of the weights in grams. And then we're going to add each of these weight categories to get a grand total for the total weight of the eggs. And then we're also going to add the number of eggs. So we have the total number of the eggs and that total number that those eggs weigh. So the total weight in grams for all of those eggs is 6,728 grams. Now let's see how many eggs actually made up that weight. So that was 100 eggs. So if we divide our total weight by our total number of eggs, it will give us a mean weight for the supplier A eggs. So that's for supplier A. We've been given the mean for supplier B. So explanation and supporting calculations are: we would buy our eggs from supplier A as the mean from A is higher at 67.28 grams per egg. And that should do as an explanation. And that question is worth 4 marks. Question 12. A man has £5,000. He will put his money into a savings account at a bank and he wants to save it for 1 year. Bank A pays 3% compound interest and it adds interest every 4 months. The formula for the bank's compound interest is below, where A is the amount of money after 1 year, P is the amount of money invested, R is the percentage interest rate, and N is the number of times interest is added in 1 year. Bank B pays 3.15% annual interest rate. Which bank should he choose? And explain your decision. Okay, so for Bank A then, there are certain things we need to put into our formula to work out the amount after 1 year. So the amount after 1 year is equal to P is the amount of money invested, and that is £5,000. Now that's going to multiply 1 plus, now R is the percentage interest rate. So the interest rate is 3. And then over 100 times N. So N is the number of times interest is added in 1 year. Now, he gets paid interest every 4 months. So we've got 4, 8, 12. So we've got our 12 months in the year. So it's going to be paid 3 times. So we're going to multiply that by 3. And all of that is to the power of 3. Now you can put that into your calculator in one go if you want, or you can break it down into stages to make it easy for yourself. Whichever method works for you is fine. So I'll break it down and I'll do 5,000 times brackets, and then I'll do the stuff in brackets first because we know that's what BidMath says to do. So we've got 1 plus, then we've got a fraction of 3 over 100 times 3. And we press the equal sign, press the SD, and we get 1.01, and that's all to the power of 3. So now I'll do the next bit. I've got 5,000, and I'm going to do 1.01 to the power of 3. So we've got 1.01, and then we choose X, and we're going to put the number 3 into our index. So we use this X here with the filled in box because it allows us to put any number as a power. We press equals and we get 1.030301. So all we're going to do now is multiply that and find out what we get. And because that long number is already on the calculator, all I'm going to do is press multiply and by 5,000. Press equals, and we get £5,151 and 50.5 pence. Now, because it's money, we're going to have to round. So we'll do our rounding and we'll take £5,151. In fact, we'll turn this into pounds. And then we'll look at the next number along and we'll call it 51 pence. So that's how much you would get after a year with Bank A. Now let's have a look at Bank B. We've got £5,000 and we multiply it so by 3.15% to find our interest. And that's £157.50 interest. So we add that to our 5,000 and we get £5,157.50 from Bank B. So we need to compare the two and find which one gives us more interest. So that would be Bank B. Scrolling down to see what else they need for the answer. Show all your working. Well, all our working out is up there in the top. And an explanation is Bank B as it gives, and then you could actually calculate the amount if you wanted to. So Bank B is 51.57.50. Bank A is 51.51.51. Take one from the other, and that's £5.99 more. And again, this question is worth 4 marks. Question 13, a magazine article has this headline: Garden birds in decline, fewer birds seen in our gardens. An environmental organisation records information about bird populations, and the graph shows some data about 2 types of garden birds. So looking at our data, we've got the chaffinch as the circles, and we've got the X's as the sparrow. Is the magazine headline correct? And that show a suitable calculation of percentage change for the last 10 years and draw trend lines on the graph to support your answer. Explain your answer and make 2 comments. So let's do the easy thing first, and let's draw the 2 trend lines and get our marks for doing that. So there's our first trend line, and here's our second trend line. Now remember, the trend lines will be different for everybody. It's how you see all of these points linking up. Now it wants us to calculate a suitable percentage of change for the last 10 years. So we need a measure in 2008 and a measure of the populations in 2018 to do our change. So let's do that for the chaffinch first. So for the chaffinch, in 2008, the average number of birds seen was 4.2. In 2018, the average is 1.6. So the percentage change is something you needed to remember, and that's the difference between the 2 numbers divided by the original times 100. So let's do the difference first. 4.2 minus 1.6. Not taking any chances, let's use our calculator. And that's 2.6. So our calculation for percentage change is the difference, which is 2.6, divided by the original amount times 100. And let's do that in our calculator. We can do it as a fraction if we want. So that's a 61.9% recurring change. So 61.9%, and that 9 is recurring, so it's near as damn it 62% as a drop of the bird population of the chaffinch. If we look at the same for the sparrow, and take the readings in 2008, which is 5.2, and we've got 4.5 in 2018. So the difference is 0.7. So our percentage change is the difference divided by the original times 100. So let's do that. We can do this as a fraction again, so we can have 0.7 as our numerator and 5.2 as our original amount as the denominator, and just multiply it by 100. And that gives us a percentage change of 13.46. So the change for the sparrow, 13.46%. Now let's look at answering our question now that we have all the data. So is the magazine headline correct? Let's remind ourselves of the headline. Garden birds in decline, fewer birds seen in our garden. So Yes, the headline is correct. And we can add as both bird types have decreased. Now your second comment could be certain bird types like the chaffinch are decreasing at a greater rate. And that would be worth the 2 marks for the comments. So the total is 5 marks for your trend lines that you've drawn on the diagram, your percentage change calculations, and your comments. Question 14. A team manager wants to pick 4 people for a bowling competition. They decide to pick players with consistently good averages, the median as the average, scoring performance. They pick the following 3 people: Archie, Baz and Kathy. They need 1 more player to make up the team, and they look at the scores of 2 more players, Dave and Elaine. Make a suitable calculation for Dave and Elaine and decide which player fits the requirement best and explain your decision. We need to find the median for Dave and Elaine, which means sorting the data and finding the middle of the data. So at the moment, the table shows the data all mixed up. So let's do Dave first. So his lowest score is 48. Then we've got 67, 78, 86, 96, 98, 101, followed by 102. So we're looking for the middle of his data. So cross them out from each end. And that leaves 86 and 96 in the middle. Add them together and then divide by 2 to find Dave's median. So the median for Dave is 91. Let's do the same for Elaine. So her lowest score is 79, and then just sort them as you see them. Once they're sorted, you find the middle, so just cancel the outside until you hit the middle, and we've got 87 and 93. Add the 2 together, which is 180, divided by 2, which is 90. So Elaine's median is 90. So decide which player meets the requirements the best. You would have to say it's Dave, and the explanation, well, the supporting calculations are above, and the explanation is Dave has a higher median score of 91, and you can leave it as that. And this question is worth 5 marks. Question 15. A fisherman sets off from Dunsey in a boat. His boat will travel at an average speed of 5 kilometers per hour. And he has this map below. He needs to meet up with a ship at coordinates L34 at 5 p.m. So L34 at 5 p.m. And he needs to know at what time he must leave Dunsey. So the first thing we need to do is plot a course for the fisherman. So we need to avoid the rocks. We can't go too close to the land. So we're going to go out, across, avoiding the rocks, and down. So we need to calculate this distance. Now, luckily, it's a nice round amount where 1 square is 1 centimetre and our scale is 1 in 25,000. We know with this scale it's centimetres to centimetres, so this is our map, this is the real world. So let's measure the number of centimetres. Now, luckily, Dunsey is exactly on one of these, so we can count the centimetres from our scale. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 centimetres. So we do the same on the other side. And we end up with 325,000. Now the 325,000 is in centimetres, don't forget. So centimetres to metres, we need to divide by 100. So that's 3250 metres. And then from metres to kilometres, we need to divide by 1,000. So 1, 2, 3. It's 3.25 kilometres. So what we need to do now is we need to go up to our speed and work out how long this journey will take. So he's 5 kilometres in an hour and we are only travelling 3.25 kilometres. So to work out our scale here, divide 3.25 by 5. Which is 0.65 as our scale. So 0.65 on one side, what you do to one side, you do to the other. So you've got 0.65 of an hour. So we need to convert that into something sensible, into minutes. So we multiply it by 60. So back to our calculator, and 0.65 times 60 will give us the number of minutes, 39 minutes. Now, we've been told that he needs to be there at 5 p.m. So if we've got 5 p.m. and we take off,
so if we've got 5 p.m. as our start point, we're going to come back in time by 39 minutes. So we can take off 30 minutes, which takes us to 4:30. Then we can take off the 9 minutes, so we're at 4:21. So the time he needs to leave Dunsey is 4:21, and don't forget it's PM. And that question in total is worth 6 marks. And that's the last question in practice paper 2. I hope this video has been of some use to you. Thank you for watching.